Okay, so section 9.2, I'm not going to make any changes to these as they are. So these are the steps for doing a state plan. Do conclude. You'll state your null hypothesis and your alternative, and define your parameter. Then you have to check your conditions, which we'll do in a second. Which are, what are the three conditions? Random, normal, independent. And then this is the do part right here. This is the do part. So you have to compute your test statistic. So you're going to figure out how far off whatever your sample says, that's your statistic. You're going to figure out how far away it is from I'll say the true population parameter, but it's whatever is stated in H naught. That's why you see a P naught here. Whatever the null hypothesis says is the proportion that you use. That's why it says P naught. That's all we have to go on, right, for these significance tests. So we're looking at, this is P hat, that's our sample, right? And we're seeing how many standard deviations is it away from the true population proportion, assuming that P naught is true, because that's what we always do. We start by assuming it's true, and then we see if we have evidence against it. So to see if we have evidence against it, we have to find what's called the p-value. So that's the probability of getting that particular test statistic. So that's going to be looking at the area under the curve. That large or larger in the direction specified by your alternative. So if your alternative is less than, we're looking for area to the left. If it's greater than, we're looking for area to the right. And we'll talk about not equal to next time. And then if your p-value is less than alpha, you already knew that, then you reject H naught. So let's walk through everything in this American Idol question. So this is extra example number 5. Still from section 9.2, and this is the situation. So on American Idol, we're wondering if there's a advantage to performing last. So there's a random sample of 600 fans, and they're shown the audition tapes of 12 contestants. The order that they're shown in, so this is like your experiment, the order that they're shown in is randomly determined. So that won't affect our results, and we would expect if there's no advantage to going last, we would expect 1/12 of the fans to prefer the last performer. So what we found is that 59 out of 600 preferred the last performer. Is that convincing evidence that going last is an advantage? So we are going to test this. We're assuming that alpha, by the way, our default alpha, we talked about this last time, is going to be what percent? Yeah, 5. We'll use alpha 5% as our default significance level. So we're going to state, first of all, we're going to state what we're interested in and to define the population parameter. So that's P is the true proportion of fans who prefer the last performer. Of fans who prefer the last performer. Very important to write out what exactly that is so that your H naught and your H sub A make sense. So then what do you think our null hypothesis is here? If P is that, what's our null hypothesis? Yeah, good. That's the statement of equality. P equals 1/12. That's if there is no preference, but what do we suspect? Which direction do we want to go in for H sub A? Yeah, that the proportion is actually greater than 1/12 because we suspect that there is an advantage to going last. Okay, so our plan is that we're going to use, the title for it is a one sample. In the last chapter it was a Z interval for confidence intervals. This is a one sample Z test. instead of an interval. There actually is, your calculator will actually do these for you if you care to look into it, but I'm not going into it. One sample z-test for proportion. So if our conditions are 2, so random, so was a random sample taken? Okay, random sample was taken, so that's, we got that one. Normal condition is we have to check number of successes and failures is NP, N1 minus P. But we use P naught, right? The proportion stated in our null hypothesis, because we don't have any other P to use. So NP is, there's 600, right, in our sample size. And P naught says 1/12. That's the proportion in our null hypothesis. So the number of successes is 50. So that's greater than equal to 10. And failures is 600 times 11/12, which will give us 550. So that's also greater than 10. So we're good on the normal condition. And independent is how many American Idol fans do you think there are? So we assume there's greater than 10 times 600 or 6,000 fans. Assume there's greater than that. Okay, so we're done with our plan. Our do. Okay, so we're finally on the do. So we take a sample now. We set all this up. We take a sample, and remember the notation for sample proportion is p hat. And what is that? Yeah, good. 59 over 600. So that proportion is 0.098. So now we want to find our test statistic and see how far away that is from the true proportion in stated in the null hypothesis. So our test statistic z, this is how we'd show it, is we just do 0.098, subtract it from 1/12. Okay, maybe point is 0.083, but make a note that that's, here, I'll put 0.083 up in the null hypothesis, just so you know that that's 1/12, right? What was stated in the null, we're using the formula now. So p hat minus p naught over the standard deviation. So the square root of 0.083 times 1 minus 0.083 over sample size n is 600. So to save time, if you do all that on your calculator correctly, you should make sure that you could get 1.33. So it's 1.33 standard deviations away. So we're gonna find the probability that that would happen. So our p value, not to be confused with p for proportions, right? P value is, so the probability is the probability that z is greater than, so we go in the direction stated by h sub a, which is greater than, right? So probability z is greater than 1.33, and we can use normal CDF to figure that out. And the default mean, the default mean and standard deviation is already 0 and 1, so 1.33 to infinity. You don't have to enter the mean and standard deviation because that's okay. So our p value is, be sure that you can get 0.0918. So do we get to reject? This is our p value, right? And this is our significance level. Our significance level, we want less than a 5% chance of that outcome happening in order to reject h naught. We want less than a 5% chance at random that we would get that outcome. So what's the probability we get it? Not, it's over 9%, right? So it could have happened randomly that many people preferred the last performer. So we cannot conclude anything. We can't reject h naught. So we can't conclude that there's a benefit to performing last. So the conclusion would be, our conclusion since this is how you say it, you'd have to say since the p-value is greater than alpha, we fail to reject H naught. Okay, so that part is formulaic. Okay, that part that you write, but then say what it means. So no advantage to performing last.
So it's only when it's less than 5%.
Exactly. It's only when it's less. If your alpha is 5%, which is going to be our default, then we can make a conclusion that H sub A is true. So no advantage to performing last is our conclusion. There's no advantage to performing